Welcome back. Let's start on example 2. So again, we're going to find the discriminant, and based on our final answer for the discriminant, we will be math magicians and we'll already know the numbers and types of solutions that your quadratic will have. Pretty exciting, right? Well, let's get started. So remember, first, it would be helpful to know what A, B, and C are so we can actually find the discriminant. Okay, so A, remember, if you don't see a number in front of a variable, there secretly is a 1. So my A is going to be 1, B is going to be 8, and C is going to be 16. All right, so let's find the discriminant. So the discriminant is going to be my B term squared. So B squared is 8 squared. Then minus 4 times A, which is 1, times C, which is 16. Okay, let's see what we get. So 8 squared, 8 times 8 is 64. And then negative 4 times 1 is negative 4. And negative 4 times 16, well, that's going to be negative 64. And 64 minus 64, well, this will give me 0. Okay, so my discriminant is going to be equal to 0 this time. So my discriminant, sorry guys, can't spell today. Discriminant, let me make sure, discriminant, okay, equals 0, sorry. Having a moment. Anyways, our discriminant is going to equal 0. Okay, so again, remember you guys, the discriminant doesn't have a square root in it, but in our formula, it's the part underneath the square root. So I'm going to envision the 0 under a square root, which the square root of 0 is 0. So I'm going to have like negative b plus 0 over 2a and negative b minus 0 over 2a, which anything, if you add or subtract 0 to a number, it's not going to do anything. So I'm going to get the same answer twice, but it's going to be the same answer. So going back to our cheat sheet, let's see here. Okay, so when your discriminant equals 0, okay, again, you're going to get the same answer twice because you're adding and subtracting 0 to a number. So it does count as two separate zeros. It's called a double root, but we're going to say it only has one solution, or however you want to call it. So one real rational root. Okay, so it does count twice, but it's the same thing. So we're going to call it as one real rational root. Okay, so for my final answer, I'm going to say, well, we're going to end up with one real rational root. And guess what? That problem is donezo.